All right, so let's start with the first page, and we're just going to walk through all of this. Okay. Now, remember I told you that if you know the answers to these, you know the answers to the exam, right? Okay. So, for those of you that need that glorious grade, it is possible. Okay. All right, so we're just going to start with the very beginning. This starts with day 1, week 1. Okay. All right, so the statistics is the science of conducting studies to collect, organize, summarize, thank you, analyze, and draw conclusions from data. Okay, that's that definition we learned about week 1 or 2. Okay. All right, variables with values that are determined by chance. The key word here is chance. What does that tell you if it's determined by chance? It's random, so your answer is random variable. Okay, which branch of statistics can employ probability to predict how many miles one should be able to drive a 2000 Toyota Celica during its lifetime? Right, because you've got this timepiece right here, it makes it a time series. Okay, what level of measurement classifies data into mutually exclusive categories in which no rank or order can be imposed? All right, so we had these 3, right? This is the one that was just categories. This one you can put them in order. That's like the first, second, and third. I'm sorry, ordinal would be the one you put in order. Sorry, I put it under the wrong one. Okay, interval is the one where you have units. So you can say from this to that. And remember, for ratio, you have to choose the units. That would be something like height or weight, where you have to choose how you're going to measure it. Okay? So in this case, because I have no rank or order, I can't put it in any kind of order. It is nominal. All right, a person's hair color would be an example of a quantitative variable. What does quantitative tell you? It's what kind of an answer? Is it a category? Is it a number? It's a number. Quantity or quantitative tells you it's a number. So is a person's hair color a number? No. So that would be false. The variable of height is an example of a quantitative variable. That is true because you measure your height in inches or feet or however you do it, and it comes out to be a number. Okay, so we're about halfway down the first page, right? Is everybody good? Okay, the number of birds in a tree is an example of a continuous variable. Now remember, discrete means you're counted. Continuous means you're measured. So do you count birds or do you measure them? You count them, so that would be discrete, so this is false. Okay, determine which of the following are quantitative data. So in other words, is it a number? The name of a chemical sample. Is that a number? No. Is the mass of a chemical sample a number? Yes. Is the color a number? No. So it would only be number 2, so it would be 8. Okay, determine which of the following, again, is quantitative. The length of an object in feet. Yes or no? Yes. The speed of an object in meters per second. Yes. The number of objects that are blue. Yes. So it would be all 3. So it would be A. Okay. Next to the last one on the page. The volume of a shipping container in gallons. Is that quantitative? Yes. The name of the material from which the container is made. No. The shape of the container. No. So, determine which of the following describes, qualitative. This one it changed. Okay. So we want the ones we X'd out. So we want 2 and 3. Okay. Qualitative would be your categories. It's not a number. Sorry, I jumped down to I was looking at the one before. Okay, we down to the last one on the page, right? Okay, let's go get it. Again, this one's qualitative, so we don't want a number. Okay, the make of a car with the driver's license number. Okay, so that one is qualitative. The license plate number. No. Well, could it be though? It has a number in it.
Teachers, pardon the interruption. We wanted to remind students that we're doing the EOC testing today. If you're taking a biology test, you need to go to the multi-purpose gym, which is the new gym back in the athletic wing. And if you're taking social studies test today, you need to go to room 211, which is upstairs on the back hallway. Again, biology goes to the multi-purpose gym. Social studies goes to room 211, and teachers, they need to report to those classrooms now. Thank you.
Aren't you glad you don't have to do that? All right. If it's a combination of the two, then it is not quantitative. Okay. Or is it qualitative? It's neither. Okay. The number of vehicles whose license plate number begins with VNS. No. Okay. So it is only number 1. Okay. Okay. Page 2. Let me make this a little bigger so you can see it. It's a little small. There we go. Okay. Which of the following data are discrete? So remember, these have to be counted, right? Not measured. Height, is it counted or measured? Measured, so it is not one. Height, is it counted or measured? Measured, so it's not one. The preseason ranking of the Duke University men's basketball team. Is that a count? Yes, it is, because we count the number of teams we have in the top 10, etc. The average preseason ranking of the University of Connecticut's women's basketball team over the past 10 years. No. Okay, so my answer is C. Now, once you find your answer, do you need to even look at D? No. Okay, use your test taking strategies. When one of the which of the following is discrete? So it means we got to count it, right? Latitude and longitude of a boat at sea. No, because that's a measurement. Latitude and longitude of the boat's port of departure. Nope, that's measured. The speed of the boat. No, because that's measured. The number of crew on the boat. Yes. Okay, which one of the following are continuous? So now we need measurement. Okay. The ranking of the trees from the numerous to the least numerous. So we're counting trees, right? So that one's not going to work. The number of species in the park. You count them, right? That won't work. The average height. Yes, so C is my answer. I don't know why these things didn't stay blown up. I blew all these up yesterday. And went back to their original form. Which one of the following data are continuous? So again, we're measuring, right? The number of files that have been downloaded. No. The time remaining on the MP3 music download. Yes, we are done with that one. If you were told that 4 students from a class of 20 were questioned in a poll about their study habits, what kind of sampling would that be? Okay. So now think about this. You got the school. You divide them up into classes, right? And you're only going to talk to somebody from this class. So which one is that? When you divide it up, but you only talk to one group. Stratify would be if I talk to one in every group. Systematic would be one every 10th person. Cluster. Cluster says you only talk to one group. Okay. What type of sampling is employed if the country is divided into economic classes and a sample is chosen from each class to be surveyed? So now I'm talking, they're divided into classes, but I'm talking to somebody from every single solitary class. So that's systematic. That's your stratified. Systematic would be like one every 5th person. Okay, so let's look at the next one. The questioning of every 14th customer leaving a theater about the movie they have seen would be an example of systematic sampling. True. Okay, that 14th is your key. I'm going to cry if you get this one wrong. Which of the following sample types should you always regard as unreliable? We want to do random, we want to do stratified, we want to do cluster, so what does that leave me? Voluntary. Remember, there's all kinds of problems with that convenience sample when it's voluntary. Okay. All right, so everybody good with those? I'm going to turn the page. Huh? Yeah, upholster is the next one. It's on the next page. Okay, upholster randomly samples 135 Democrats, 164 Republicans, and 16 independents, all registered voters in the metro city, and ask each poll participant which mayor candidate he or she prefers. Identify the kind of sampling. So you've divided into parties, right? Democrat, Republican, Independent. And I'm taking a poll of each one. So which one is that? Stratified. Very good. Okay, now we start with this part. This is the part where you start thinking about your graphs. If you have an upper class boundary for a histogram, okay, let's just say I'm drawing a histogram. Yeah, I know my bars are leaning. What kind of numbers are down here? Are they whole numbers or do they end in something specific? Limits are going to end in whole numbers, right? Think about your frequency table. This is your class limits. Then you have your class boundaries. Okay, and let's say this one is 10 to 21. What do you put right here? What do you do to this column to get from this column to this column? Do you remember? What do you subtract from this and add to this? 0.5. So this would be 9.5 and 21.5. Okay, and that's the numbers that would be down here. This would be 9.5, this would be 21.5. Okay, so when you're looking at these, you need to look at the language. Does it say class boundary? This one says class boundary, so that means it's got to have a 0.5 on it. And I want the upper class boundary. So I want this 35, and I'm adding 0.5. So your answer is C. Okay, now the next one says I want the lower class limit. So it doesn't have a 0.5 on it. So what's my lower number in my class? 13. Okay. All right. On this one, you need to think about what is the distance between here and here? Because remember, the class width is always from the start of one class to the start of the next class. So what is the difference between 100 and 90? 10. So the class width is 10. This says if I have a class from 5 to 9, what is the upper class limit. So that means I want the one that doesn't have the 0.5. So my upper number is 19. So my answer is B. What are the boundaries for the class 11 to 18? So that means I've got to subtract 0.5 from this one, and I've got to add 0.5 to this one. So that's going to give me 10.5 to 18.5, which is A. Okay? Any questions on that part? Blow this up a little more if I can. Can't go too far with it. Okay. Greg wants to construct a frequency distribution from the political affiliation of the employees at Owen's hardware store. What type of distribution is that? What is a political affiliation? Is it a number? Is it a category? What is it? It'd be a category. So this is categorical. So if you just identify what you're trying to put into a distribution, then you'll know what kind of distribution it is. All right, now these should be the easiest questions ever. The class with the least number of data items. What's your lowest bar? 85 to 95. Okay, the class with the greatest number, so what's my tallest bar? 55 to 65. If you miss those two, I will cry. Don't make me cry. Okie doke. All right, the cumulative frequency for a class is the sum of the frequencies of the class less than or equal to the upper boundary of that specific class. So here's what I'm asking. Cumulative frequency, do you add the frequencies as you go down? Yeah, I do. So that would be true. Okay, on the next one, it says, here's my 25 scores. Do the tallies and the frequencies for these. Okay. So we're just going to go through and do them. I'm going to make me some lines, though, because y'all know my line of vision just is not real good. I won't be able to figure out what I'm doing if I don't do this. Okay. So now that I have lines to go by, it should be okay. Okay. All right, so let's just go down through here. 63 would be in this one. You want to go down or across? Down? Okay, 55 would be in this one. 81 would be in this one. Got 277, so I should have 2 in there. I have 86 would be in this one. I have 89 in that one. 82's in that one. 87 is in that one. 79 is in there. 77 is in there. 63. 44. We finally got one in the first class. 74. 45, 51, 68, 80, 91, 87, wait a minute, that was 91. I'm missing one or something. I'm going to put it down here.
I think you cut off.
Did I? Yeah, because I got a 91 here. Okay, so I'm going to add that on the bottom because it should be down there. 67. I need to check that on the exam, make sure I didn't cut that off. 96 should be in this bottom one. 90 should be in that one. 59 should be in that one. And 97 should be in my last one. So my frequency should be 2, 3, 4, 6, 7, and 3. Is everybody good? Everybody still writing? Okay, let's look at the next one. Now, there's a lot of words here, right? At the top. Do you necessarily need all those words? Probably not. How many students memorized the number in 3 trials or less? So they're trying to memorize an 8-digit number. Okay, and they have to recite it until they look at it, and then they try to recite it and how many ever times it takes them. So the key on this one is 3 trials or less. So that means I want the number at 3. So I want this one, and I want anything below it. So I need to add those up. So 10 plus 2 plus 1 is going to give me 13. So my answer is B. Okay, so there's a whole lot of words there that you really don't even need. An ogive is also called a cumulative frequency graph. Now think about what you do when you do an ogive. When you do an ogive, you do boundaries down here, and you do cumulative frequency this way, right? So it's the same thing as a cumulative frequency graph. So that would be A, because that's what you use to make it. Okay. Which direction should an ogive always go, up or down? If you're doing cumulative, because you're adding, right? It should always go up. Okay, which is the key to the next question on the next page, page 5. Okay, so page 5, got 5 and 6 to do. All right, this says, which of the following could be a cumulative frequency graph? That means that graph has to go up. So which one of those graphs always goes up? D. A histogram is a graph that represents the cumulative frequencies for each of the graphs of the frequency distribution. Now think about what you put on a histogram. You have boundaries down here, but what do you have over here? You just have frequency, right? Not cumulative frequency. So this is false. If you took out this word, it would be true. Okay? But because that cumulative word is there, it makes it false. Okay? All right. On to the next one. I know I can make this one bigger. There we go. Okay. Given the frequency distribution, how many pieces of data were less than 85.2? 28.5, sorry. Can't read. Okay. So I want everything less than that. So I don't want any of these, right? I want everything above that. So I need to, add all those together. So 12 plus 9 would be 21 plus 4 more is 25. The following bar graph represents the average amount of certain families spent in dollars on various food categories in the recent years. On which category was the most money spent? Which one of those is the highest? Dairy products. Okay, we have finished with page 5. Okay, page 6 requires a little more work than you think it does. Okay? I want you to think about making a circle graph. Okay? The first thing I need in a circle graph, if I'm going to figure out what these percentages are, is I need a total, right? I need a total. So I need to add calculator up. I need to add 9, 20, 25, and 39, right? So I get 93 is my total. Okay, so my total right here is 93. So to find my percentage, I need to take these numbers up here and I need to do 9 divided by 93 and turn that into a percent. So let's do that. 9 divided by 93. All right, so this is going to be, if I move that decimal place over 2 places, that's going to be 9.7, right? 9.7. Now, they were nice to you on this question. There's only one that's 9.7, and it's this one right here, so that has to be my answer. Okay, all your percentages on these are all different. So you just had to know that you had to add those up and divide and turn it into percent. Okay, once you did one of them, you were done. Okay, could you have gone through and done them all? Absolutely. You do 20 divided by 93, 25 divided by 93, 39 divided by 93. I had somebody the other day tell me that I always do the biggest one. Fine, whichever one you want to do. Okay, it's going to give you the answer. Now, once you realize that none of the other ones have the same one and you find your answer, you don't need to do anything else, right? So don't waste time doing stuff you don't need to do. Okay, that's one of those test taking skills things I want you to use. Okay. All right. Going to the next. Everybody good for me to turn the page? Okay. A weatherman records the amount of rain that fell in Portland, Oregon each day for a year. What type of graph should he use to show the rainfall changes during the year? So is he going over a period of time? Yes, he is. So that means the only graph I have that goes over a period of time is a time series graph. Okay, now, by knowing the answer to the next one, you would have been able to answer the one above it, right? A time series graph represents data that occurred over a specific time period. So that would be true, because you had to go over a specific time period. A Pareto chart does not have which of the following? Okay, so let's just go back through a Pareto chart. Remember, Pareto chart has you're going to have categories, and they have to go from greatest to least, like this, right? Okay, so this would be your Pareto chart. Okay, cumulative frequencies are ordered from highest to lowest. Yes, that is one of the properties. Quantitative variables are on the horizontal axis. What did we just say these are? They're categories, right? They're not numbers. So this is not a part of a Pareto chart. Classes must be categorical, frequencies displayed on the verb. Okay? In a pie graph, it is not useful in showing which of the following characteristics of a data set. Frequency changes over time. Okay, if it's over time, what kind of graph should that be? That should be a time series. So this guy is not going to work for a pie graph. This should be a time series. You can do relative frequencies. You can do categories that make up the smallest to the largest portion, but anything over time is not going to work. Okay? All right, I will give you the option. We can continue through page 9, and then you will only have 10 through the end tomorrow, or you can work on your writing section and work on the rest of the review. What would you rather do? It's your option. Keep going? Okay, we'll go through page 9, and then tomorrow you'll have the rest of them, so you'll have everything by the end of Thursday. Okay? So you can start studying and doing whatever you need to do. Okay? All right, so let's keep going. Page 7. I have them all on here, so it doesn't matter what we do. All right, a time series is useful for which of the following purposes? Now, we need something that talks about time, right? So this is the representing, this is not going to work. Smallest to largest, that's not going to work. Representing the changing frequencies of a data category over a period of time. Well, that works. Okay, cumulative frequencies is not going to work. Relative frequencies is not going to work. Okay, now I think we just answered this question, didn't we? It's just a little bit different words. A time series graph is useful for detecting trends that occur over a period of time. That is true. Detecting of trends is just watching what happens over a period of time. Which graph should be used to represent the frequencies with which certain courses are taken at Highlands Middle School? Okay, so a course is a category, right? Okay. So we want to know the frequencies. So we need an order, right? So which one does category and order? Time series does over time. Pie graph does not put it in order. Pareto, does it put it in order? Largest to smallest, right? So it would be a Pareto chart. A pictograph is just pictures and you put how many for each one, but it doesn't put it in order. A pie graph would best represent the number of inches of rain that has fallen in Ohio each day over the last 2 months. What is this? It's false because that's time. So what should we use if it's time? Time series, right? Not a pie graph. Okay? All right, these next 3, you're just asked to do the graphs that go with these. Okay, so let's go through these. Blow it up so I can make it a little bigger. Okay, remember that a stem and leaf plot must have a what? A key, because we have to know how to divide it. So in this case, since we don't have decimals, we have to divide it between the 2 numbers, right? So let's do 1/9 equals 19. Okay, so here's my stem. I have a 1. What's my biggest number? 63. So I gotta have 1, 2, 3, 4, 5, and 6. Okay. Now I gotta put these leaves over here. I gotta put them in order. And I'm gonna draw lines on mine just so I don't get my lines all messed up. Okay, the only one I have that has a 1 in the front is my 19, right? All right, so let's go through my 20s. I have a 21. I have a 24. Does anybody see one before that? I have a 28. And I have a 20, where'd it go? 29. Sorry, a while ago. Okay, now for 30s. I have 2 30s, so I have 2 zeros. I have a 30. That's 3 30s, you're right. There it is. That's the third one. And then there's a 36, 2 36s side by side, and 39. Okay, I have 43 is my first one. Then I have 46, 47, 48. Then I have 52, 53, 54, 58, and my last one is 63. Okay. Any problems making that one? Okay. All right. Let's look at the stem and leaf plot for the next one. Now, we have decimals on this one, so what's my key going to look like? Where's my separator going to go? Let's use 9.3. Where am I dividing? At the decimal this time, right? So I got to have my first one is a 2. So I got to have 2, 3, 4, 5, 6, 7, 8, and 9. Okay. All right, so I have 2.4 and 2.5. Do I have any 3s? No. No 4s. So my next one's going to be a 5. So I got 5.4. Has anybody seen the other ones? All right, then I got 6. Do I have 6? Yeah, 6.6. I have a 10 too. No, okay. All right, then I have 7.0. I just saw it. There it is. 7.0. 7.1. 7.273s. Okay, I have a 7.4. I have a 7.7. Okay, then I have several 8s here. I have 8.4 is my first one. Then I have 8.7. I have 2 of those. There, one there. I have an 8.8. I have 2 8.8s. Okay, and I have an 8.9. Then I have 3 9.3s. 1, 2, 3. And I have a 9.6, a 9.7, and a 9.8. And I have a 10.4 and a 10.9. Okay. Okay, any questions about the stem and leaf plots? All right, now the dot plot at the bottom, you can do these with X's or you can do with dots. I don't care which way you do them. Okay, the only numbers we have down here are 12, 13, 14, and 15. So I need a spot for 12, a spot for 13, a spot for 14, 15, and 16. Okay, you want to do dots or X's? X's. Okay. All right, so I have 1, 2, 3, 4, 5, 12s. So I have 1, 2, 3, 4, 5 that way. Then I have 1, 2, 3, 4, 5. It's like I have 5 13s also. So 1, 2, 3, 4, 5. Those two are going to be the same height. Then 1, 2, 3, 4, 5, 6. 14's 1, 2, 3, 4, 5. 1, 2, 3, 6. There we go. Top. And then I have 1 15 and I have 2 16s. Okay, so you're just looking for the dot plot that has the 14 that has the most because it had 6. The two other ones had 5. Did I miss a 15? I did? Okay, so I need to put another 15 on there. I was like, why did I not cross that off? Okay. Any questions on that one? One more page down. I'm going to wait because some of you are still drawing.
Yes, sir.
I just did take the indicator off of it. Okay. Ready for the next page now? Okay. On this one, what kind of chart is this? That's what it's asking. It's highest to lowest, so it's a Pareto. So your answer is B. All right, a Pareto chart arranges data from the largest to the smallest. That is true. Okay. All right, on these, I don't care how you find these, whether you do them in the calculator with the list, whether you just put them in the calculator and do the average, how you want to do them is up to you. Okay. So on this one, I have 13, 15, 21, 20, and 22, and I need to find the mean. Okay. So I have 1, 2, 3, 4, 5 numbers, so I can add them all up and divide by 5, or I can put them in the list and let it do it for me. Okay, doesn't matter which way you want me to do it. You tell me. Anybody need to see the list? I'll do the list if you need it. Otherwise, I'm just going to do this. 13 plus 15 plus 21 plus 20 plus 22 5. And I got 18.2, which is D. Okay, the median is the middle number, but what do you have to remember to do before you choose the middle one? Put them in order. So I have 3, 5, 8, 10, and 14. My middle is my 8. Okay, if you forget to put them in order, then your answer is going to be different. It's going to be wrong, right? Okay. Any questions to right there? Because once we turn the page, then we're going to have to use the list. Okay. All right. You have a list of numbers up here. Yeah, you can still do it the old way. Okay, but it takes a heck of a lot longer to do it the old way. Okay. So it asked me to find the mean of this, of all of these up here. So I'm just going to put them in the list, okay, and let it find the mean, because down here it asked me for the median, right? And you're going to find something interesting when you do this. Okay, so I'm going to go to Stat, Edit, and go up and clear my numbers. And then I'm going to put these numbers in. 21.65, 32.7, 6. I'm going to go back and double check my numbers here. Make sure I got them. That doesn't look right. 11, this should be 4160. That would make a difference. Does anybody think any of those numbers are out of place? Like the $14 and $11.99? Unless they're buying regular gas and everybody else is buying diesel. All right, so we need the mean and the median for these, right? So once you have them in the list, where do you go? Stat, Calc. Make sure you're in list number 1. Go down to Calculate. Okay, so my average is 35.88, which is which one? It's A. Okay, 35.88. Okay, then it says to do the median of those same numbers. So I've already done that, right? It's just down here below where I can see, so I have to arrow down. So this says the median is 4188. Is 4188 on there? No. So we're just going to write out to the side out here, 4188. Okay. Okay. The next one says, find the mean of the data in the stem and leaf plot if the leaf represents the ones digit. So what they're saying is this is 12, 12, 13, 23, 24, 28, 28, 28, 37, and 41. Okay, so I'm going to put those. You want to put those in the list, or you just want me to add them together? There's 10 numbers, so we can do it either way. Just add them up. Fine with either way. All right, so let's clear this. So in my parentheses, I'm going to do 12 plus 12 plus 13 plus 23 plus 24, and there are 3 28s. 1, 2, 3, a 37, and a 41. 24.6. Okay, so my answer is B. Okay, all right, last page. Okay, this goes back to when we talked about normal distributions and we started talking about variance and standard deviation. Okay, all right, in a unimodal symmetric distribution, in other words, if you have a bell-shaped curve, okay, we have a bell-shaped curve, and you're told that it is a normal distribution, what did we say about all the numbers that fall right here? All of your mean, your median, and your mode all fall right in the middle. So they're the same. So your answer for this one would be A. Okay, you would have to know that this right here means normal distribution. Okay. The variance in a set of data is the square root of the standard deviation. How do you get from variance to standard deviation? Do you square it or you take the square root of it? They're saying that the variance is the square root of the standard deviation. Are they right? That's backwards. It should be the square root of the variance is equal to the standard deviation. So that is false because it's backwards. Okay, the range of a set of data items is when you subtract the highest and the lowest. True or false? True. Because the range is equal to max minus min. So that is true. Okay, this may help you in some of your writing stuff too. So we're going to talk about those percentages for Chevy Chevs. Okay, we're ready? I didn't want to turn before you were ready. All right, let's just go back through these. When you do empirical rule and you do Chevy Chefs, you have standard deviations, right? So we have 1, 2, or 3. What is your percentage for empirical rule for each of these? Do you remember them? 68, 90,
5 and 99.8. Yeah. You just got them backwards. Okay. Chevy Chevs, 1. Is there one? None. Okay. 2. You're trying to do 3. 75 and 80. 80. Now, what can you do if you don't remember that? It's on the writing portion, so where can you go look? In your notes. Or Google Classroom or Google. There you go. Okay. So if you were going back to the notes, let's just do this as if we were doing this question because this is going to help you do this. All right. So let me close this. So I don't know what the answer to this question is. So I'm going to go to my Google Classroom and I'm going to go to my classwork. And I know that that was back from a unit that's called normal distributions. If you just go down, you can probably get to it quicker. Oh, come on. And so y'all thought I was being a pain in the neck when I did this. But anything you open that says in the normal distributions, what is it going to have on the top? It's going to have those percentages on it because I harped on them. Okay? So you just open anything that says empirical rule or Chevy Chevs. Let's just do day 2. That's just the worksheet though. Let's do day 1. Okay, here's my notes. Open my notes. Run down through here. Oh, there they are. Okay. So all you have to do is go get those, right? Okay. And that is actually an answer to one of your questions, right? On your writing section. Okay. So you got all those. Okay. I'm going to erase these from up here. Need my eraser to be bigger so they're not in the way. Okay. So Chevy Chevs can be used to find the minimum percentage of values in a data set where that fall within a certain distance of the mean. So you have standard deviation. So that's a certain distance from the mean. So that would be true. We're going to get back to those down here. Determine the range of the following data set. Now, what did you tell me range was? Highest? Max minus mean. So I got 22 is my max. My min is 3. So that would be 19, if I did that right in my head. Okay, the grades of a trigonometry exam are listed below. Find the range. Okay, what's my highest? 93. What's my lowest? 75. So the difference between those is 18. Okay? Now these next two have to do with that Chevy Chev's empirical rule. Okay? The average resident of the metro city produces 570 pounds of solid waste each year, and the standard deviation is 70 pounds. Use Chevy Chef's theorem to find the weight range of at least 75% of its residents' annual garbage waste. How many standard deviations does this tell you? 2. So I have 2 standard deviations. So my standard deviation is 70. So 70 times 2 is 140, right? So that's going to be the distance from my mean, and my mean is 570, so I need to do 570 minus 140, and 570 plus 140. And that will give me my range. Well, you should only have to do one of those, right? Because they're all different. So this gives me 430. So that tells me it's going to be A. You can either do the top or the bottom because all the answers are different. Okay, last one on that page. Ready? I think I put it on a page by itself. It wouldn't fit. All right, this one says a paint manufacturer discovers that the mean volume of paint in a gallon-sized pail is 1 gallon with a standard deviation of 0.05 gallons. The paint volumes are approximately bell-shaped, which means it's a normal curve, right? So that means I'm doing empirical rule, okay? So remember that this tells me right here that I'm doing empirical rule. Estimate the percent of pails that are between 0.95 and 1.05. So my average is 1, okay? So I'm subtracting something and I'm adding something, and I need to get 0.95, and I need to get 1.05. So what am I adding and subtracting here? How many of these am I subtracting and adding? Just the one. So what's the percentage for one standard deviation on the empirical rule? 68. Okay, now, if you knew that was bell-shaped and you know those percentages, you could have done this right here before you ever started, because those aren't part of my empirical rule percentages. Okay, so that would be an easy get rid of A and C. So then I just got to figure out how far away these two guys are to figure out whether it's 1 or whether it's 2. Okay, that's another way to go at it. Okay. All right, so tomorrow on the video, I will do the last half of the review. Is there anything you need to ask me about the writing portion or anything of that nature? Okay. So you have the rest of the time today to work on the rest of the review or makeup work or writing section. Okay.